Hello friends, welcome to the new chapter, Projection of Lines. We start with session 1 on projection of lines. Now, initially, we'll try to understand the real basics involved in projection of lines. Once you understand the basics, you can manage any complex problem given in the examination. See here, projection of lines basics. You see here, line AB 50 mm long is parallel to both HP VP. The line is 60 mm above HP and 50 mm in front of VP. It's a simple problem. I'll just tell you here. See here, this is VP, this is HP. And always assume, see here, this AB is the line. Okay, AB is the line. And if you see here, this AB is the line which is parallel to VP, parallel to HP. Okay. This AB, in front of VP it is 50 mm, above HP it is 60 mm. Okay, it is this line AB, line is AB. Okay, this is 50 mm in front of VP, 60 mm above HP. And the requirement here for this basic problem is when the line is in this way in the space, that is in front of VP above HP, that is first quadrant. Please understand here afterwards. We do problems only in first quadrant. Throughout here, from here, it is only problems in the first quadrant. That means it is in front of VP, above HP. Okay, this is the thing. First quadrant problems only. Okay, now this line AB is measuring 50 mm long. Correct? No? It is 50 mm in front of VP, 60 mm above HP. You have to draw the projections. When you draw the projections, the front view of this will be here. And the top view of this will be AB. Front view will be A dash B dash and the top view will be AB. Drawing front view and top view itself is called projections. Okay. Now this is XY line, VP HP. You see here, this is AB is the line, what I have shown in red. Okay, this line is in the space. It is 50 mm in front of VP, 60 mm above HP. Okay. And you have to draw the front view and top view for this. Front view A dash B dash, top view AB. Now, if you know very well, when you draw XY, VP, HP and all that, front view A dash B dash, whatever is the distance above HP, I have told you in the last sessions and all that in projection of points, whatever above HP will be seen in VP. That is why the 60 mm is parallel to VP. As a result, A dash B dash, you write it at 60 mm. Front view, write it at 60 mm. Then also I told you, any distance in front of VP is parallel to HP and is seen on HP and is seen on HP. That is why the top view AB you will write from XY line 50 mm. That is, if this is 50 mm, this will also be 50 mm. Okay, in that way 50 mm. That means looking at this, you clearly say the line is 50 mm long and its true length, actual length is seen in the front view, actual length is seen in the top view. As a result, you can clearly say it is parallel to VP, parallel to HP because its actual length is seen in front view as well as top view. Like this, it is parallel to VP, parallel to HP. In that way, I have drawn one front view and top view for this basic problem and I have taken care of these dimensions also. 60 mm above HP is parallel to VP. That's why it is seen on VP. 50 mm is parallel to HP and is seen on HP. In that way, the basic problem 1 is covered. Okay, now see here, a line PQ is inclined at 30 degrees to HP and parallel to VP and measures 60 mm. One end is 20 mm above HP and 40 mm in front of VP. Draw projections and all that is there. Okay, here a line PQ is inclined at 30 degrees to HP and parallel to VP. See here afterwards, you see here, line PQ is this. Please carefully understand. Okay, line PQ is this, inclined at 30 degrees to HP and parallel to VP. Can you understand? Okay, this is VP. It is parallel to VP. Okay, and measures 60 mm. And also I have told you one end, if you see here, parallel to VP and measures one end is 20 mm above HP. One end of the line, no, P is 20 mm above HP and the entire line is 40 mm in front of VP. Okay, 40 mm in front of VP. Please observe, this is, though it is simple, you have to understand the concepts here. Now see here, XY I have written VP, HP, okay, This is the first quadrant system and all that. The line is PQ, red one. Okay, line is PQ, which has been kept in the space in this position. How it has been kept in the space in this position? That is, the line is inclined at 30 degrees to HP. Okay, 30 degrees to HP and is parallel to VP. It is parallel to VP. Okay, one end P, no, it is 20 mm above HP. And the entire line, it is parallel to VP. No? The entire line is, how much it is in front of VP? 40 mm in front of VP. Okay. Now, what you should know here afterwards is, if a line is parallel to VP, its true length or actual length, we call it as actual length or true length, is seen in VP. Okay. If a line is parallel to VP, its actual length is seen in VP. In case if the line is parallel to HP, its actual length is seen on HP. Now, line is parallel to VP. That is why its actual length is seen on VP. Okay. That is why this length is 60 mm. Same 60 mm line you write in VP. Okay. But one end is 20 mm above HP. No. This is 20 mm above HP. P is 20 mm above HP. Above HP distance is seen in VP. That is why this 20 you take it here. Okay. 60 mm and is inclined at 30 degrees to HP also. 30 degrees to HP also you write it. Okay. Once you draw, the corresponding top view is a reduced length. You don't know this length. This length depends on the inclination here. If 30 degree becomes 40 degree, this top view length goes on reducing. This length reduces. If 40 becomes 50, it still reduces. Did you follow? In that way, the top view length depends on the line's inclination to HP. Okay. Now, 40 mm, why I have taken is, the line is 40 mm in front of VP. I have given here, okay, 40 mm in front of VP, 40 mm in front of VP, 40 mm you take the projectors here and draw the top view line here, PQ. Okay, here, after drawing XY line, VP, HP and all that, you can't start from the top view here because you don't know the top view length. You have to start from the front view only because in the front view, actual length, the line length measures 60 mm. That is actual length, the true length is seen in the front view. That is why we start from the front view here. P dash, Q dash, you draw first at an inclination of 30 degree and measuring 60 mm. Since P, one end P in the problem they are given is 20 mm above HP, you take 20 mm above HP here. Okay. And the line is 40 mm in front of VP. That is why once you draw this front view, okay, you draw the projectors down and draw the top view at a distance of 40 mm. This is the front view, this is the top view for this problem. See carefully, I am telling you, you try to understand. These are not difficult things, but in case they make any small changes in the examination, okay, you must immediately know. Even later in the actual problems in lines, main problems in lines, we'll come across such problems. Here, the line is parallel to VP, inclined at 30 degrees to HP. When it is parallel to VP, I have told you, you have to start from the front view. That is why I started from front view. If the line measures 60 mm, it has to be seen as 60 mm. If it is parallel to VP, the actual length, the true length is seen in the front view. Okay. And one end is 20 mm above HP. Correct? No? And the line is 40 mm in front of VP. Okay, 40 mm in front of VP, I have drawn. In case they say, I am telling you, one end of the line is touching HP means this P should touch HP, no? One end is actually 20 mm above HP. If it is touching HP, the 20 becomes 0. As a result, you make 20 0. You start P dash from here only. P dash, Q dash at 30 degree you draw here. Okay. Did you follow? In case I say one end of the line is touching HP. Here in this problem I have told one end of the line is 20 mm above HP. In case if I say one end is touching HP, immediately make P dash on XY line. P dash on XY line. Okay. And in the same way, you see here, if I say one end touching HP means put P dash on XY line. Sometimes no, they say line is lying in VP and inclined at 30 degrees to HP and all that. Line is lying in VP means this line 40 mm in front of VP should not be there because it is lying in VP means it should be touching VP only. Okay. Under such circumstances, 40 will become 0 and you are writing this PQ on XY line only with one end 20 mm above HP. Okay. Did you follow? Small changes. See here, I'll tell you, don't complicate things. Now I have drawn a problem where line is parallel to VP. Okay. Line is parallel to VP because true length in front of you. Line is parallel to VP, inclined at 30 degrees to HP, measures 60 mm. One end is 20 mm above HP, 40 mm in front of VP. This is the problem. In case they say one end touching HP, immediately 20 mm above HP, make it 0. You make it P dash on XY and P dash Q dash, you write it this way. Okay. Forget it. The problem is this way. In case they say line is lying in VP means the distance in front of VP should be 0. Immediately make PQ on XY line. Okay. In that way, any changes if they say you should be in a position to do. Okay. See here, significance of the locus in the front view. Okay. Significance of the locus in the front view. You see here, same problem. Let us say line is, see here, line is 60 mm, inclined at 30 degrees to HP and parallel to VP. For that, P dash Q dash is the front view, PQ is the top view. Okay, PQ is the top view. Now, please understand that. What I am telling you is, clearly understand, P dash Q dash is the front view, PQ is the top view, which we have just now done. Now, keeping 30 degree constant. Now, right now, it is parallel to VP. Parallel to VP. Okay, it is parallel to VP. Okay, that is why you can see PQ at parallel to XY line and all that. In case the line is, now the line is inclined at 30 degrees to HP, parallel to VP. Okay. Keeping 30 degree constant. Okay. I can move the line this way or I can move the line this way. That means if I rotate the line, P is fixed. P is a fixed point. I'll move Q. That is, I'll move Q either towards VP or towards observer. Observer is anyway here. Okay. In the entire process, I'll not change the inclination to HP. 30 degrees to HP will be constant. In that case, what exactly happens is the top view length does not change. Even if you take a random position here, PQ1 will be equal to PQ only. Let us say I'll move it this way. This is PQ2, which is equal to PQ only. That means as long as inclination to HP constant and if you rotate with respect to VP, okay, now it is parallel to VP. If I do start doing this way, parallel to it is inclined to VP. Even if I do this way, if I rotate the line in this way also, it is inclined to VP only. Now, as long as inclination to HP constant, if you rotate the line with respect to VP, the top view length does not change. PQ will remain same. That is, let us say I'll go to some random position here. This PQ will be equal to PQ1 only. Let us say the line is moved this way. PQ will be equal to PQ2 only. Also, as long as inclination to HP constant, and if you rotate a line, the distance of end Q above HP will remain same. That means it will be lying only on this locus. This you never forget. Okay. That means as long as inclination to HP is constant, keeping P fixed, if you rotate the line with respect to VP, whether it is Q1 or Q2 position, any position, the distance of end Q above HP will remain same. That is the significance of the locus. That means on the locus only the line should lie. That is point should lie. If Q1, no, even in this position, the Q1 height above HP should be on the locus only. Q2 distance above HP should be on the locus only. Okay, in that way, you don't forget, as long as inclination to HP is constant, with P as fixed, if you move the point Q with respect to VP, if you rotate the line with respect to VP, keeping P fixed, two things what you observe is, one is the distance of end Q above HP remains same, and also the distance of the top view, the length of the top view also remains same. This is very important to observation to be made. This is the end of session 1 on projection of line. Thank you very much for watching. We'll continue in session 2. Thank you.